Hello everyone, as you all know that I am your science expert, and today in this video we are going to take up very interesting topic, that is metals and non-metals. So let's explore this topic, that is metals and non-metals. So let's see that what topics we are going to cover in this interesting chapter. So let's sum them up. So the first topic we'll be taking up is the introduction about metals and non-metals, in which we'll learn that what exactly the metals and non-metals are. Second thing, we'll be doing the physical properties of metals and non-metals. Then we'll move on to the chemical properties of metals and non-metals. Then we'll study the metallurgy, that is the process of extracting metal, that we are going to cover in the metallurgy part. Then we'll move on to the chemical bonding, and the last topic we'll be discussing about the alloys. So these all topics we are going to take up in this video. So let's start with the introduction first. So just look at the board. As you can see that we have a complete table, and this table is called as periodic table. And you can see that inside this table we have the columns. We have the vertical rows and we have the horizontal rows. Vertical columns, they are called as groups, and the horizontal columns, they are called as periods. So this complete is a modern periodic table. Now what is the need of this modern periodic table, who gave it, or what is the use of it, that we'll take up in the periodic properties. But at this moment I am making you familiar with this table just to start this chapter with the simple term, that is the elements. Now you can see that inside the periodic table we have certain symbols written. Now what are these symbols? These symbols represent the elements. These all symbols are of different elements. Now the question must be coming to your mind that what do we mean by element? Because before learning or moving to metal and non-metal concept, you should know that what exactly the element is. So element is a substance that cannot be broken down into more simpler substance. I'll repeat and you just write it down. Elements are the substances that cannot be broken down into more simpler substances. Right. So these all are the elements. Now if I talk about the number of elements discovered so far, so there are 118 elements which are discovered so far. Right. And out of them, the maximum of them are naturally occurring and few of them are synthetically made. Right, they are made by the nuclear reactions. So I think you got it that there are 118 elements that are known till now, and out of them the maximum, almost 94 elements, they are naturally occurring. Right, and the left one are synthetically made in the lab. Now, I think you got it that what exactly the element is. Now, in the periodic table, we can see that there are so many elements. In periodic table, the elements are arranged according to their nature. Nature means that like what properties they actually possess. As you can see that on the left hand side, all the elements which are there, they are metals. And all the elements which are on the extreme right, they are non-metals. This last group, that is the 18th group, it contains the noble gases. Noble gases are the gases which have stable octet. That means their electronic configuration is stable. They obey octet rule. Their outermost shell is fully filled. So this 18th group comprises of noble gases. So these are metals, these are non-metals, right? And like you can see that in between we have certain marked elements. They are metalloids. Now what are metalloids? Metalloids are the elements which resemble metals as well as non-metals in their properties, right? And in the middle you can see that there are few metals which are placed. They are called as transition metals. They are called as transition metals. And also you can see that on the lower side we have the two horizontal rows, right, which is not otherwise accommodated in the periodic table, in the main body of the periodic table. Those elements are called as inner transition metals. Got it? Metals, non-metals, metalloids, transition metals and inner transition metals. Now if I talk about the elements, the elements are basically divided into different categories depending upon their properties. They can be metal, they can be non-metal, they can be metalloid, they can be transition metal, or they can be inner transition metal. I think you are aware of the term element now, and you know about the metals and non-metals. So now we are going to start with the detailed study of metals and non-metals. So first thing I would like to ask you that what do we mean by metal? What do we mean by metal? We all know that we have the electrons, we have the protons, we have the neutrons in an atom. We all know that, right? And how the electrons are arranged in the different orbits, that means it is the electronic configuration. That represents its electronic configuration. And we also know about the valence shell, that while we are writing the electronic configuration, the last shell of an atom is called as valence shell. And the electrons which are there in the valence shell, they are called as valence electrons. So now we'll be using that concept here in order to define metals and non-metals. So the first thing is, metals are those elements which possess 1, 2 or 3 as a valence electron. Like you can see here, I have one example. So you know that sodium, like if I say sodium is a metal, prove. So how are you going to prove that? We can prove by taking into consideration the physical and the chemical properties. But now at this moment, as we are not aware of the physical and the chemical properties, so we'll be defining the metal in terms of the electrons which are there in the valence shell of an atom. We all know that sodium is represented by a symbol Na. This is a symbol for sodium, that is Na. Now, if I talk about its atomic number is 11. Its atomic number is 11. So that means the protons which are present in it are also 11. And even the electrons are 11. Because we know that in any neutral atom, the number of protons are always equal to number of electrons. So that means protons are 11, also the electrons are 11, right? And if I need to know about the electronic configuration, so I can write in a way that is 281. So the electronic configuration for sodium is 281. And the valence shell in this case is KLM. That means M is the valence shell. And if I talk about the valence electrons, how many valence electron can you make out from this configuration? Obviously, the electrons which are there in the valence shell of an atom, they are termed as valence electrons. So in the valence shell, we have only one electron. So that means in case of sodium, valence electron is 1. So it is a metal. It is a metal. So any element which possess 1, 2 or 3 as valence electron, that is the electron in the valence shell, that is termed as metal. That is called as metal. So first definition is this. Second, we can define in a way like it possesses 281, right? So that means it doesn't obey octet rule. And what do we mean by octet rule? That is the tendency to attain 8 electron in the valence shell. It possesses only 1. So that means it doesn't obey the octet rule. But it can become stable, and how it can attain the stability? By losing this 1 electron. So metals possess 1, 2 or 3 as valence electron, and they can attain stability by losing their valence electron. And when they lose their valence electron, let's take an example. We have sodium, right? The configuration is 281. It will lose 1 electron because after losing 1 electron, it will acquire 8 electron in its last shell. That is the valence shell. So it will lose 1 electron, that is minus 1 electron, and as a result, it will form electropositive ion, that is sodium ion, Na positive. And the nature is, it is electropositive ion because it carries a positive charge. Now the question must be coming to your mind that from where do we get this positive charge, right? So we know that initially the number of protons were 11 and number of electrons were 11. And in any neutral atom, the number of protons and electrons are always same. Now it is losing 1 electron. Losing means now the electron becomes 10 in number. So that means now the atom, it no longer remains neutral. So which charge is increased in it? Obviously the positive charge is increased, and by how many units? 1 unit. That is the reason sodium acquired plus 1 unit charge, and it becomes the electropositive ion, that is Na positive ion. So this is how we can define the metal. So I think you got it. So now let's move on to the non-metals, that how we are going to define the non-metal. So non-metals are those elements which possess 4, 5, 6 or 7 as valence electrons. So if I have one example, that is if we talk about sulfur, we know that the symbol for sulfur is S. If I talk about its atomic number is 16. So let's write it, atomic number 16. Now if I talk about the number of protons in it, protons are 16. And we know that, as I told you, in a neutral atom, protons and electrons number is same. So that means electrons are also 16. By looking at the electrons, we can write the electronic configuration. So it becomes 2, 8, 6. Right. Now in this case, the valence shell is again M. And how many electrons can you see in the valence shell? There are 6 electrons which are actually called as valence electrons. So that means it is a non-metal. It is a non. So if I ask you that is it stable or not? You will say that no ma'am, it is not stable because it doesn't obey the octet rule, because it possesses only 6 electrons as valence electrons. So that means sulfur can somehow attain stability by gaining 2 electrons. So sulfur, that is S with electronic configuration 286, it will gain 2 electrons plus 2 electrons and will form 288, right? And it will form the electronegative ion. It will form the electronegative ion, that is the sulfide ion with S2 negative charge. Got it? So we can define the non-metal in a way. First thing is that they are those elements which possess 4, 5, 6 or 7 as valence electron. Second thing, that they always, or you can say they have the tendency to gain electron, to accept electron, and after accepting they form the electronegative ion, as you can see in case of sulfur. So we have so many metals, we have so many non-metals. So I think you are now in a state to define that what exactly are metals and what exactly are non-metals. Now we are going to learn about them in a detailed manner, and there we are going to consider the physical properties, and then we will move on to the chemical properties. Let's start with the physical properties of metals and non-metals. So the first property I have for you is the malleability. So we need to know that what exactly the malleability is. See, malleability is a process of beating the substance into thin sheets. It is a process of beating or metal or any other substance into thin sheets, right? So if I talk about metals, metals are malleable. That means they can be beaten into thin sheets. So most of the metals, they are malleable. As you all know that when you go out for a picnic or when you carry your lunch box, you actually wrap your food items in the aluminium foil. What exactly is aluminium? Aluminium is a metal because it also possesses 3 valence electrons, and it also has a tendency to lose electrons. So aluminium is a metal, and it also possesses the property of malleability, and that is the reason you wrap the food items in that thin aluminium foil. So that means metals are malleable. If I talk about the non-metals, non-metals are not malleable. Non-metals are non-malleable. They do not possess this property of beating into thin sheets. The reason being they are brittle. They are brittle because in order to make them into thin sheet, we have to hammer them. And we cannot hammer them because they are brittle. So we cannot convert them into thin sheets. But the exceptions do exist, right? Like if I talk about metals, I told you that metals are generally malleable. But the metal like zinc, arsenic, antimony, etc., they are non-malleable. We cannot beat them into thin sheets. Similarly, if we talk about the other metals like silver, gold, they are also metals, but they are highly malleable. Right. So in general, if somebody asks you, so we will say that metals are generally malleable and non-metals are generally non-malleable. So let's move on to the second property, that is ductility. That what do we mean by ductility? You must have noticed, like when you make use of any electrical device, we have the wires which are attached to it, which carries the current. The wire which is present inside it, that is the copper wire. That is the copper wire, and we know that copper is a metal. So the ductility refers to the process of drawing a substance into thin wires. You know that we can we can make the wire from silver also, we can make the wire from gold also, right? And copper wire I already told you. So metals, they possess the property of ductility. That means we can draw them into thin wires. But if I talk about the non-metals, non-metals are non-ductile. Again, the reason is same, because they are brittle. In order to beat or draw them into thin wires, we need to hammer it. And we cannot hammer it because when we hammer, it breaks. It is brittle in nature. Again, the exceptions do exist, like zinc, arsenic, antimony, etc. These metals are non-ductile. We cannot draw them into wires. So if somebody asks you about the ductility property, you should be quick with the answer that metals in general, they are ductile. Like we have gold and silver, they are the best ductile metals, and non-metals are non-ductile, the reason being they are brittle in nature. So let's move on to the third property. So the third property is electrical conductivity. Electrical conductivity, and also we will learn about the heat conductivity. Do you know that what exactly the electrical conductivity and the heat conductivity means? Electrical conductivity refers to the tendency of a substance to carry the current from itself, and heat conductivity refers to the tendency of substance to conduct heat through it, right? If we talk about electrical conductivity, any substance can act as a conductor only if it possesses the free mobile electrons in it, right? And the substance which doesn't possess these free mobile electrons, that is non-conductor. So if we talk about metals, I already told you that they possess extra electrons which they lose. So that means in them free mobile electrons are present. That makes them to act as a conductor. But if I talk about non-metals, I told you that they are acceptors. They need electrons in order to attain stability. So they do not possess those free mobile electrons. So they are basically non-conductors. Got it? And if I talk about the heat conductivity, we know that heating effect is produced only because of the electrical conductivity. Because when the electrons move, they collide, and due to which the heat is produced. So heating effect is one of the core application of the electric current or the electricity. So that means any substance which acts as a conductor is a good conductor of heat as well. That is the reason we make use of copper wires. Right, as I told you, whenever we need to operate any electric device, we make use of copper wires. They are best for the electrical transmission. So, because they are good conductor of heat as well as of electricity. Got it? But if I talk about non-metals, they do not possess those free mobile electrons. So, that is the reason they are poor conductor, or we can say they are non-conductor, and they do not allow current to pass through them. And even if we talk about their heat conductivity, it is not up to the mark. Got it? So metals are good conductors of heat and electricity, and if we talk about non-metals, they are bad conductors, or they are poor conductors, or they are non-conductors of heat and electricity. Got it? As you all know, the exceptions do exist, like non-metals are poor conductors. But if we talk about the allotrope of carbon, that is the graphite, that is exceptionally good conductor of heat and electricity. You have to remember all these exceptions. They are very important, and you may encounter a question like this in your paper, that name a non-metal which is liquid at room temperature, or name a non-metal which is good conductor of electricity, like that. So you need to remember these exceptions. So the next property that we are going to talk about is the luster nature. What do we mean by luster? If you bring something like from market, sometime the substance is like that, it shines. So that property of shining means that the substance is referred to be lustrous. So lustrous or a luster simply means the shine. So if we talk about metals, they are lustrous. That is, they have the property to shine. Right. Now if we talk about metals, they possess the property of being lustrous because they shine. right? But the exception do exist, as I told you. Sodium and potassium, they are non-lustrous. They do not shine. And if I talk about non-metals, in general, they are non-lustrous. They do not shine. But again, the exception exists, that is the iodine and the allotrope of carbon, that is graphite. They have the property to shine. Right, so I think you got it. Let's move on to the next property, that is the hardness. Right, so if I talk about metals, metals are quite hard because in them the atoms are tightly packed together. Right, but we encounter two metals which are so soft that we can cut easily with knife also. And those metals are sodium and potassium. So this is very important, and you may get a question like this: name two metals which can be cut with knife. So those metals are sodium and potassium. They are so soft that we can easily cut with the help of knife. Now if we talk about non-metals, they are generally soft in nature. They are generally soft. But as we are discussing that the exceptions do exist, so the exception, that is the allotrope of carbon, that is diamond, it is the hardest known substance. So I think you are aware about the hardness and the softness of metals and non-metals now. Let's move on to the next property, that is the melting and boiling point. Now what do I mean by this term, melting point and boiling point? Melting point and boiling point refers to the temperature at which the substance starts melting or the temperature at which the substance boils. So if any substance is hard, that means the atoms inside it are closely packed, so obviously we need to supply more amount of heat in order to melt or in order to boil it. So we all know that metals are quite hard because in them the atoms are tightly packed. So we have to supply them with more heat in order to melt or boil. That is the reason they possess the high melting and high boiling point. But as I told you, sodium and potassium, they are exceptionally soft. So that means if we talk about their melting and boiling point, that will also be low. That will also be low in comparison to the other metals. Now if I talk about the non-metals, like we discussed, they are soft in nature. So obviously their melting and boiling point will be on the lower side, right? Because they are soft, we need to supply them with lesser amount of heat in order to boil or in order to melt them. So got it? That melting point and boiling point, if we talk about metals, they possess generally high melting and boiling point, and non-metals, they possess the low melting and boiling point. So now let's take up the another property, that is the physical state, that how do they exist at room temperature. So if we talk about the metals, they are generally solid at room temperature. See here I have few examples for you, and as you can see that sodium, this is how sodium exists, that is in the solid form. This is potassium, this is how it exists, again in the solid form. So likewise, most of the metals, they exist in the solid form. Now here I have two metals, just have a look on the board, right? These metals, they exist as liquids at room temperature, right? And they are mercury and gallium. So you have to remember this, that mercury and gallium are such metals which exist as liquid at room temperature. But in general, metals exist in a solid state. Now if we talk about the non-metals, they can exist in all three states. That is, few exist as solids, few exist as gases, but there is only one non-metal that exists as liquid, and that is the bromine. So if we talk about like how many non-metals exist in a solid form, they are 10 in number, right? And if we talk about that how many of them exist as gases, they are 11 in number. And liquid, I already told you that there is only one non-metal that exists in a liquid state, and this question might come in your exam. So you need to remember it, that bromine is a non-metal which exists in a liquid state at room temperature. So got it? So this is all about the physical state. Let's move on to the next property, that is the sonority. What do we mean by it? Sonority or sonorous, it means that when we hit the substance, the sound is produced, right? So sonorous means when you are hitting anything and you can hear the sound, that means the substance is sonorous in nature. Now, if you have any metal around, just try to tap it. You can hear the sound from it, Because metals are sonorous in nature. Metals are sonorous in nature, right? So metals are sonorous in nature. But if we talk about non-metals, they are non-sonorous. That means when you hit them, they do not produce any kind of sound. Got it? So these are the physical properties on the basis of which you can classify metals and non-metals.